Hello to all my geometry friends. Today we are going to look at the Pythagorean theorem. The Pythagorean theorem is almost certainly the most well-known theorem in geometry and perhaps in mathematics in general. It is a powerful theorem and it is not difficult to demonstrate. So let's take a look.
Mr. Wade, are we going to do a formal proof?
Excellent question, Zorg. We are not going to write a formal proof, but we are going to demonstrate why the theorem is true using properties of both geometry and algebra. Writing it out as a formal proof is more time-consuming and we will do that later. However, this demonstration could be easily written out as a proof. So let's get started. For this demonstration, it will be helpful to remember that if two triangles are congruent, that means all of their corresponding parts are congruent. And the area of a square is found by squaring the side length. In other words, multiply the side length times itself. We will start with a square. Let's call it square A, B, C, D. We start with a square because it has 4 congruent sides and 4 right angles. Let's look at side A, B. We pick a point anywhere on side A, B. Then we locate points on the other side so that the purple segments are all congruent to each other. We color the segment that remains on each side blue.
So Mr. Wade, am I correct in concluding that the segments in blue are also congruent by using segment subtraction?
Brilliant, Zorg.
Thanks.
Let's mark the figure. Now let's connect the 4 new points with segments. We now have a new quadrilateral and 4 right triangles. Do you see the right triangles, Zorg?
Yes, I do.
What do we know about the right triangles?
They are all congruent by the side, angle, side, postulate for triangle congruence.
Brilliant once again. Now, by the definition of congruent triangles, what folks often call C, P, C, T, C, we get the sides of the inscribed quadrilateral to be congruent as well as the corresponding acute angles of the right triangles. Now, what do you know about the acute angles of a right triangle, Zorg?
They are complementary.
Correct. And so, angles 1 and 2 are complementary. And since angles 2 and 3 are congruent, we can say that angles 1 and 3 are complementary as well by the transitive property. Since acute angles 1 and 3 and the angle of the inscribed quadrilateral, angle 4, form a line, we know they are to 180 degrees. We can subtract the measures of angle 1 and angle 3 and be left with 90 degrees for angle 4. The same logic applies to the other 3 angles of the inscribed quadrilateral and so we can conclude that it is a
square.
Raise your hand please, Zorg. But you are correct, it is a square. I have labeled the segments in the figure so that the blue segments have a measure of A, the purple segments have a measure of B, and the sides of the inscribed square, which are also the hypotenuses of the right triangles, have a measure of C. Now we will calculate the area of the big square using 2 different methods. Can you think of 2 ways to do that, Zorg?
Yes, we can use the formula for the area of a square, side squared, and use A plus B as the side length. Or, we can add the areas of the 4 right triangles to the area of the inscribed square.
Brilliant again, Zorg. Let's look at how that will work. First, the area by adding the 4 triangles to the inscribed square. The area of the right triangles is 1/2 A times B. There are 4 of them, so it's 4 times the quantity 1/2 A times B, which simplifies to 2A, B. Then add C squared for the inscribed square. Next we calculate area using the side of the big square. The side of the big square is the sum of A and B. So now we square the sum of A plus B, which simplifies to A squared plus 2A, B plus B squared. We set those areas equal to each other and then subtract the common value of 2A, B, and bingo. A squared plus B squared equals C squared.
So, the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse.
Correct. This is just one way of demonstrating the Pythagorean theorem. There are many other methods. Thanks, and we will see you soon.